Bismillahirrahmanirrahim, dear students. Assalamu alaikum. I am Razi and I'm here to teach you the basic concepts of mathematics. And I'm going to start 5.2 exercise. Students, we already have done many work on partial fractions, and today we are going to start our new exercise, that is 5.2, and it will contain a denominator in which there will be repeating linear factors. So let's start. Students, it is the second case of partial fractions, and case 1 we have already learned. So as I already have mentioned that it will contain the linear factors, repeating linear factors in its denominator. So students, we're going to solve the example number 1 at page 184 that is included in your syllabus. So x square plus 1 minus 1 over x plus 2 whole cube. The first rule, the first necessary step that I have mentioned in my previous lecture was that first of all you will have to check whether the given fraction is rational, proper or improper. So the given rational fraction is proper fraction, so we are not going to divide this rational fraction because the degree of numerator is 2 and the degree of denominator is 3. That's why we will not divide it. We just make the partial fractions of it. So first partial fraction will be a over x plus 2. The second partial fraction will be b over x plus 2 whole square, and the third will be c over x plus 2 whole cube. Remember students, a simple linear factor, if it has only power 1, it will have only one rational partial fraction, and if it contains power 2, then there will be 2 partial fractions, and if it contain the number of powers n, it means it will have the rational fractions of number n. N mean any number from 1 to infinity. So moving on, when we multiply the both sides by x plus 2 whole cube, we will get x square plus 1 x square plus x minus 1 is equal to a into x plus 2 whole square, because x plus 1, that is in denominator, will cancel out one power. Similarly, b into x plus 2 only of degree 1, because the power x plus 2 whole square, the double factor have been cancelled out by this denominator, and the only single factor remained, and plus c, because all the three factors x plus 2 whole cube are cancelled with the factor x plus 2 whole cube that we are multiplying on both sides. Moving on, x square plus x square plus x minus 1 is equal to a into x square plus 2ab, that is equal to 4x plus b square, 4 plus b into x plus 2 plus c. Now students, the first value will be obtained by putting a linear factor is equal to 0. And remember students, in this question we have only one linear factor, we have only one linear factor, that is x plus 2. So x plus 2 is equal to 0. We are putting x plus 2 is equal to 0, which means the value of x is equal to minus 2. So when I put minus 2 in place of x, I get minus 2 whole square plus minus 2 into minus 1 is equal to a into 0. As in second equation there is x plus 2, so it will be 0, and similarly b contains x plus 2, so it will also be 0, and plus c. When we solve this equation, we will get c is equal to 1, because minus 2, the square of minus 2 is 4, and minus 2 minus 1 is equal to minus 3, so 4 minus 3 is equal to 1. So the value of c is 1. Now we have no other linear factor that we can put is equal to 0, so we are going to compare the coefficients of x square and x, because we need to find only two unknowns. That's why we are not going to compare the unknowns on from both sides of the equation. When we equate the coefficients of x square, we will get a is equal to 1, because on left hand side, students, because on left hand side there is x square containing 1 as its coefficient, and on right hand side there is only one x square and the coefficient of x square is a, so value of a is equal to 1. Without solving, without doing anything, we have calculated the value of a. But when we compare the coefficients of x, the coefficient of x on left hand side is equal to 1, and on the right hand side there are 2x. In first term, the coefficient of x is 4 multiplied by a, so it will be 4a, and in second term there is only b, so 4a plus b is equal to 1 is the equation that we are going to solve. So when I solve this equation, the value I put the value of a, that is 1, so 4 ones are 4, and 1 is equal to 4 plus b, it will give us the value of b. 4 from right hand side to, it will be moved on to left hand side, and it will become minus 4, so minus 4 plus 1 is equal to minus 3, so the value of b is minus 3. Hence the partial fractions are, now we are going to put the values in equation 1, that was a over x plus 2, so the value of a is 1, so it will become 1 over x plus 2, but the value of b is minus 3, so negative sign will replace positive sign, and the term become minus 3 over x plus 2 whole square plus 1 over x plus 2 whole cube, as the value of c is 1. So students, we have learned that how we can solve the uh, denominator containing the same factor with repeating power, with same factor with many terms. Moving on, students, the next example is 1 over x plus 1 whole square into x square minus 1. Students, it's the second example of at the page 184, and we are going to solve it by the same method as we have used in previous question. So students, first we solve the denominator as x square minus 1 is equal to x plus 1 into x minus 1. So when we put it, as we will get x plus 1 whole cube into x minus 1, it means that the x plus 1 has power 3, so it will be make as three partial fractions, and x minus 1 will have only one partial fraction. So moving on, students, we make the partial fractions of this as a over x minus 1 plus b over x plus 1 plus c over x plus 1 whole square plus d over x plus 1 whole cube. When we multiplied x minus 1 into x plus 1 whole cube on both sides, we will get 1 is equal to a into x plus 1 whole cube, b into x plus 1 whole square into x minus 1, c into x minus 1 into x plus 1, and d into x minus 1. Students, this equation will be, the second equation will be used to calculate the unknowns of linear factors, but we make another equation that will be used to compare the coefficients, that is 1 is equal to a and 2. We are going to open the formula of x plus 1 whole cube, x cube plus 3x square plus 3x plus 1 into b into x square plus x minus 1. I first opened x plus 1 whole square, and then the answer is multiplied by x minus 1 plus c into x square minus 1. You know, x a plus b into a minus b is equal to a square minus b square, and d a into x minus 1. Now students, we are going to put the linear factors is equal to 0. The first factor is x minus 1 is equal to 0, means x is equal to 1. When we put x is equal to 1 in above equation, we will get 1 is equal to a into 2 raised to power 3, because all other terms containing the x minus 1 will be equal to 0. So 2 cube means 8. So 8a is equal to 1 and a is equal to 1 over 8. Similarly, when we put x plus 1 is equal to 0, we will get d is equal to minus 1 over 2, and we will get two values by comparing the coefficients of x cube and x square. When we compare the coefficient of x cube, we get a plus b is equal to 0, b is equal to minus a, and we have already find the value of a 1 over 8, so b is equal to minus 1 over 8. And when we compare the coefficients of x square, we will get 3a plus b plus c is equal to 0, means 0 is equal to 3 over 8, as the value of a is 1 over 8 and the value of b is minus 1 over 8, plus c. When we move 3 over 8 minus 1 over 8 to the other side by taking the LCM, we will get minus 1 over 4, the value of c. In the end, students, we are going to put the values of a, b, c and d in equation 1. So when we put the value of a we will get 1 over 8 into x minus 1, and when we put the value of b, we will get minus 1 over 8 into x plus 1, and when we put the value of c, we will get minus 1 over 4 into x plus 1 whole square. And last but not least, the value of c is minus 1 over 4 into cx plus 1 whole cube. So students, that's all from my side today, and I'm sure you will have learned something today from my lecture. I suggest that students, please, you must do practice at homes, and for practice I'm going to give you two questions from 5.2 that are question number 4 and question number 6. That's all students.